We are going to start off chapter 6 by graphing systems of equations. A system of equation is two equations that share variables, and the variables that are the solutions to one are the solutions to the other. So today we're going to look at graphing as a method of solving systems of equations. So we're going to graph the two lines, and where they intersect is the solution. So if we look at this first example, y equals negative 6x plus 4, and y equals 2x minus 4. We're going to graph the first line, so we're going to start at plus 4. And we have a slope of negative 6, so we'll go down 1, 2, 3, 4, 5, 6 over 1. Down 1, 2, 3, 4, 5, 6 over 1. We could also have gone up 1, 2, 3, 4, 5, 6 and back 1. And we connect the dots. There's one line. When we look at our other line, we start at negative 4. And we go up 2 over 1, up 2 over 1, up 2 over 1, or down 2 back 1. And then we connect the dots through. We see where they intersect right here, and they intersect at the point 1, comma, negative 2. Now, we may need to rearrange our equations into slope-intercept form before we graph. That's okay. So if we have 3x plus 4, or 3x plus y equals 4, and x plus 2y equals negative 2, over here we're going to have to subtract 3x, and we get that y equals negative 3x plus 4. Over here we're going to subtract x, get 2y equals negative x minus 2, divide everything by 2, and now we get that y equals negative 1/2 x minus 1. So now we have our two equations to graph. Start at plus 4, slope of negative 3. So we'll connect these dots. There's one equation. Now we go for our other. We start at negative 1. We have a slope of negative 1/2, so we go down 1 to the right 1. Down 1 to the right, down 1 to the right, or up 1 and back, up 1 and back. Once we do this, again, we connect the dots and see that there is our solution at the point 2, comma 2. Now, let's look here. We have y equals, that's x plus 4, and y equals x minus 2. So we'll start at plus 4. We have a slope of rise 1, run 1, rise 1, run 1. For this section, it's important that your graphs span the entire graph. Your line spans the entire graph, because we need to see where the intersection is going to take place. And our other one, y equals x minus 2. We have minus 2, and we'll go up 1 over 1, up 1 over 1, down 1, back 1, down 1, back 1. And when we connect the dots, oh, what do we notice about these lines? These lines are parallel. And so parallel lines have no solution. These lines never cross, so therefore there's not going to be a solution to these lines. Parallel lines have no solution. So here we have x plus y equals negative 2 and y equals negative x minus 2. We need to rearrange a little bit and get that y equals negative x minus 2. And I'm going to graph that, minus 2, and have a slope of negative 1. And I go to graph my other line, y equals negative 2, slope of negative 1. It's the same line. Well, if we have the same line, where does this line intersect? Everywhere. If it's the same line, we have infinitely many solutions. Infinitely many solutions. Not all real numbers, because not all pairs of numbers work. Only this pair of numbers that's the line, this set of pairs that's the line works, but we have an infinite number of solutions since the line jets all the way that way and all the way back this way. Now, on your practice problems worksheet, we have more examples, so we'll do one together. So y equals negative x minus 4, we'll start there. minus 4 with a slope of -1, so we'll go down 1 and over 1, or up 1 and back 1. And we'll connect the dots, make sure it spans the whole thing. And then we have y equals x minus 2, so we start at minus 2, and we have a slope of up 1 over 1, or down 1 back 1. When we draw our lines, we see that it intersects here at -1, -3. Remember, all of our answers are written as ordered pairs because they are the collection or the answers of x's and y's. So we're going to write our answers to solutions as ordered pairs. Have fun.